Chapter 3, Statistical Inference. So we will cover on sampling distribution, inference for single population, inference for two population, and non-parametric statistic. But for now, just until 3.4. Introduction. What is descriptive statistic and statistical inference? So we have descriptive statistic is summaries organized and display set of data numerically or graphically, and statistical inference is a sample size using sample for making generalization about population. Here we have population, we take a sample and then randomly, so from the sample we make the calculation, we draw the conclusion and about population and make inference about population. Okay, so from sample we can estimate what's about the result on the population. So population and sample, the different is for example in table 3.2 we have all female student in University of Malaysia Police. For the sample we take a random sample for 30 UNIMAP female student. That is the difference lah. So population is all car battery produced. The keyword is all. For sample, there is a selected set only, a sample, a random sample, something like that. Maybe if we have 100 population, maybe we just take 20 data only. That is a sample. We take the smaller from the population amount. And statistic. What is parameter? Parameter is belongs to population. Where, for example, we have a numerical measure which describe a population, but statistic is a numerical measure which describe a sample. So what we calculate before this or later, there is a statistic. We call it as a statistic. For parameter, it belongs to the real population. Population parameter is fixed. There is an example here, and then there is example for statistic. make a sample statistic, which is we calculate it and so on, cari mean, cari variance and so on. Estimate the parameter, and then kita estimate the parameter, maksudnya kita buat conclusion pada parameter tu, and then parameter tu draw about the population punya estimation kita lah. So kita ada two statistical type inference: parameter estimation, hypothesis testing, which is hypothesis testing is based on the sample evidence we test and claim the population mean lifetime to 1,000 hours. And parameter estimation is estimate the population mean lifetime using the sample mean lifetime. Distribution, what is sample distribution? Sample distribution is simply distribute. A sample distribution is a distribution for all possible value for a sample statistic measure on the repeated random sample of each size and drawn from population of interest. We repeatedly mengulang kali mengambil data. That is, we call it as a Y repeatedly sample from the population. So we will have from population, we have first sample, second sample, until maybe until 100 samples size. So sampling distribution, we have sample means and sample proportion. What is sample mean? Sample mean when the population of interest is normally distributed, and distribution of sample mean will be normal distributed regardless of size of sample. The normal, And then if for proportion, if NP greater or equals to 10 and NP greater or equals to 10, distribution of sample proportion will be approximately normal. Okay. Okay, here we have relationship between population distribution and sample distribution. We have three relationship. We have center for both distribution in the same. Dispersion of sample distribution is narrow than population distribution. Okay. The sample size is sufficiently large and sample distribution will be approximately normal regardless the shape of the population. Central limit theorem. What is central limit theorem? If all sample of certain size of drawn from any population, the sample distribution of sample statistic is approximately normal distribution. The explanation improve with larger sample size. So we have a smaller sample size or right line, and the larger sample size. So larger sample size give us a normal distribution. Okay. So this is called as a central limit theorem. More larger sample size, more normal that our data. If sample size is sufficiently large, the sample distribution of sample statistic is approximately normal regardless the shape of the original population. Here we have inference for single population. So we have only one population. So we have a point estimation and interval estimation. Point estimation is a point estimate a single value. Ada satu je value to estimate unknown population parameter. Untuk kita estimate the parameter lah. Yang parameter ni daripada mana? Daripada population asal tu. Untuk estimate. Interval ni maksudnya interval lah. So dia tak ada point satu, dia cuma dia ada range of values. Okay, kalau kita tengok sini, dia ada range of value. Kita ada that value, which is every value inside the interval will be our range of estimation value. Point of example of point estimation, we have for population of interest, production of all 20 mmSQ in a week. Sample mean length of a random sample of 50 screw is collected and corrected, then the measure is the length of each screw. So they are the mean. This is a single point estimation. This is one example lah. So we just only have a one point, which is the mean length of 50 screw is 18.90 mm. So we have here the interval estimation. So we have unknown. If unknown is new, we denote it as a new. P new minus new 1, P1 minus P2. So point estimation here, we denote as instead of new, we x bar, P hat, and x minus 1 minus x2. So for interval, we have the notation of less than equal, less only, less than. Meaning here there is a interval estimation. Okay, confidence level of margin error. This example, if we have P and Q, so every point in P and Q, there is our interval estimation point. Confidence interval level margin error. What is confidence interval? Associated with an interval estimate state how likely the interval will consist actual value of the unknown parameter. So here we have confidence level alpha, critical value alpha divided by 2. So this value, critical value, is come from our table at the end of our book. Okay, it depends on the question, either to consider alpha 0.1, 0.05 or 0.01. So confidence interval is a certain range with associated level of confidence or confidence interval. Confidence interval CL allow us to estimate actual value of unknown parameter with a certain confidence interval. Okay, margin error. What is margin error? Margin error is a maximum possible distance between a point estimation and actual value of the parameter satisfied the confidence interval. So what is 2 times of E? So we have here the margin error, point of estimation. And then this is an error, and then the error is depends on our confidence interval. We have 90% confidence interval, 60%, 55% confidence interval, and 99% interval. So confidence interval for the mean. So we have known data and unknown data, which is unknown data is if n greater or equals to 30 and n less than 30, we have these two formula. So we need to identify first unknown data or known data. So this is example. A random sample of size n20 is drawn from the population of interest with known standard deviation. Based on the sample data, it's found that the mean of student weight kilogram is mean x bar 64.3 kilogram, and construct and interpret 95% confidence interval for the population mean nu sigma 55 kilogram. So we have new. What is new? We have here new is a population mean weight of all students. Okay, that is new. So the sample size we take here is 20. N is 20, so consider alpha. What is alpha here? 95% confidence interval, meaning we have alpha equals to 0.05, Z alpha equals to 1.96, hence 95% confidence interval given by this. So we just take the formula and put everything inside here. We have 9.96. 1.96 is come from the table, and 15 over 7 over 20 square root, and then we get the interval estimation lah. So this is minus, this is plus. That's why we get the interval. So here we have 95% confidence that the mean weight of all students between 97.73 kg and 7.87 kg. So we have two tail here. So in between that we have 17.8. So this is the graph. And then for example 3.2, this is unknown data. We have a Unimed researcher conduct a survey determine mean waiting time for a treatment at the emergency room from the several government hospital. From the random sample of 30 emergency room, there is found that the sample mean waiting time is 174.3 minutes with a standard deviation of 40.3 minutes. Calculate the point estimation and interval estimation for population mean waiting time with 99% confidence interval. Interpret the interval. So new is a population mean waiting time for the treatment emergency room. So point of estimation, we have S bar 174.3. So we take this formula because new N is 30, unknown data, but we have the sample is 30. So we have 99% confidence interval. So we have 0.01 alpha divide by 2, we have 0.005, which is equals to, okay, this refer at the table at the back, 2.5758. So put in the data, so we get this interval. So we have 99% confident that the mean waiting time for a treatment at the emergency room is between, so this is the conclusion, between 555.35 and 193.25. So you can do the exercise.
So we have n equals to 35. So we extract the data from the question first, what we need, and then construct the formula. Put into formula and we can construct the point of estimation or interval of estimation. Okay.
Confidence interval for proportion. So we have for proportion with 1 minus alpha 100% confidence interval for proportion given by this formula. So we have n sample size, x is a number of unique character of interest in the sample, and then p hat is s over n. Okay, and then p be a proportion of a student with a limited amount of time for self-learning P, and the corresponding sample proportion, sample of n equals to 1,500 students are randomly selected, and is found that 600 students agree that the limited amount of a time self-learning. Construct the interpret 95% confidence interval for the proportion for all students. We have limited amount. So we have 95% confidence interval. Alpha equals to 0.05. For Z alpha is 0.025. We divide by 2. So from this we can get from the table at the back. So we get 1.96. So it's given that P hat is 600 over 1,500, which is equals to 0.04. Then we can take to this formula. Just put in the formula. So we have the interval, confidence interval for proportion. Okay, how about if we construct the 99% confidence interval? So the problem is we just replace this value, alpha value, and z alpha value. Okay, so it become 0.01. So 0.01 is 0.0